Okay, this is the next part of my development journal, so I'm going to talk about the scaling of this app, some of the concerns I'm thinking about, have run into along the way, and yeah, I'll show some of this code operating while we do it. Previous videos I talked about just sort of basic what the app does. This is a couple weeks ago. Yesterday I threw this one up too that's talking about the daemon interaction of this app. So this is going to pick up from there. So if you're confused, go back and watch some of that. In this application, when I drew this this box right here, I put single thread processing queue. That was sort of an initial version. For scale, I actually found a way to thread the database accesses. So if there's lots of requests coming in for different pieces of art, they take different locks and access these file systems independently, which gives some speed. So that's just one minor inaccuracy. I didn't. That's just out of date. So the concern here is I want lots of, I'm invoicing pixels, and then like these are small things. Ideally we want lots of transactions per second, lots of clients all buying art and buying pixels, so that's a lot of Lightning Network transactions. Of course the market's not big. I'm not, this isn't really a business case. I'm just trying to design sort of ideal software for this to make sure I'm not shooting myself in the foot for down the road. So lots of requests come in. Of course, for every single one, we got to invoice to C Lightning, and then that invoice gets paid back from C Lightning, and then we need to update. So this is going to benchmark kind of my transactions per second. So the very first thing to note, so when I showed the other demos, I'm using this mock C Lightning. I'm still using mock C Lightning. But I'm doing it in a slightly different way. Rather than calling this via the CLI, I'm actually giving it the option to use memmock. So what that's doing is just taking this class and holding it in memory. It's bypassing all the shell interaction to C Lightning, because shelling out from Python takes like about 1/10 of a second, and that just kills my throughput. And by putting it in memory, I'm more closely modeling this PyLightning script, which is in the C Lightning repo. And what this PyLightning script does is it talks to C Lightning over RPC, and it avoids JSON. It avoids all those slow things that are in the process of invoicing. It's just being more direct. So that's really what I'm emulating here. So I believe it's going to be in the ballpark. I haven't actually done real testing, but this is kind of one of the underlying assumptions here. So if I start my back end, the first thing I'm going to do is I'm going to load some art into it. So actually the piece of art that I'm loading is in fact this rare Pepe, the Bad Lieutenant Pepe. So what that did, I just loaded it in. So here you can see on the back end, it wrote all these files. So if I just go into sorry about this, didn't prepare this. Okay, so it wrote all these files, and yeah, so what this is, it's like a database of the Merkle tree that I calculated from the pixels. For example, it's got a database for the paid invoices. Obviously no pixels have been paid at this point. It's got a database of the pre-images, and various other things along with the original image, and what the colors of all the pixels, among other things, to make quick lookups of those sort of things. The other thing, I covered this in the previous, I have to actually attach the art for it to show up. So if I didn't start my server yet. So if I start the server, which is talk to that, and refresh that, there now it sees the art, and it can see that it's 400 by 560. Do the same here on Chrome, just so I got the two browser sessions going at the same time. For the next thing, I'll just load a bigger piece of art. So what this is the $1 Million homepage, which you should be familiar with as a piece of internet history. So what I'm doing is, yes, so I'm same deal. Now this is going to take about 20 seconds, if I recall correctly. So as it's going, it's slowly populating the databases. It's doing that as quick as it can. And yeah, as I mentioned, like, yeah, this is a stall of the application. That's not a huge deal because, as I mentioned at the start, there's different threads. So if I'm loading one piece of art, that doesn't stop other guys from processing in parallel at the same time. I don't have that rigged up right now, but yeah, that does in fact work. Okay, yeah, so that's done. So this is 1,000,000 pixels. So this Merkle tree is actually like 96 megabytes. If I'm reading that, yeah, 96 megabytes, that makes sense. And yeah, the pre-image is 32 megabytes. So this is a little bit of hard drive spacing. Actually, this image is only like 400K. So it's kind of an expansion. Now this was sort of the target size. This is a fairly complex thing. This is the size of Satoshi's place. So, so yeah, that's kind of like a large image as far as what our scaling concerns go. So yeah, I gotta attach that guy. Yeah, I'll attach that guy. So yeah, so he showed up here. Yeah, if I were to enter this, now this is where I need improvement. So if you notice there, it took a couple seconds for us to actually get into the art. Now what I've got going on, if I can get into the Chrome panel, okay, it didn't actually, oh yeah, okay. So it's pulling the art down, and these are Satoshi prices, so this is a big blob of JSON. So I'm just throwing a big ass blob of JSON that has millisatoshi prices for each pixel, which these are all rendered here. You know, the price increases, I think I gave it a gradient of price increases, so it's like, you know, 8 satoshis down there, but up in the corner, that's up as 1. So this is a very, very large blob of JSON, so that takes quite a long time to transfer. So that's more or less like the entire state database. So if I want to, yes, redo this one. Okay, so if I want to then enter the $1 million homepage, this is 1,000 by 1,000. So you got all the JSON right now, so this is just actually the web browser choking on trying to parse the JSON. Yeah, finally it was able to parse. Chrome actually does a lot better job of parsing JSON than Firefox right now. But yeah, this is a pretty big usability barrier, and that could be easily fixed by replacing this kind of clumsy JSON format with like a binary blob, you know, to be able to encode this in binary and maybe even do gzip compression, because yeah, the state database, that's 50 megabytes worth of is that 50 megabytes? No, sorry, that's only 5 megabytes. Yeah, but that's still a lot of state. So 5 megabytes, but then it gets expanded to actually fit into JSON. So it'd be ideal to just have 5 megabytes of binary state and then gzip that to send it. Okay, so let's talk transactions per second. That's kind of the main point. So people have done benchmarking on C Lightning and you know, just to kind of figure out what the state of micropayments and frequent micropayments are. So Renee did this video. See the ticker here. He's just benchmarking how many transactions per second. So I think during this video it approaches 10. I think other people, you know, in good conditions, you might be able to get 30. I'm not sure what the story is, but that's kind of just where my mental peg is of where a good amount of transaction throughput is, because that's really what we kind of understand what C Lightning is capable of there. So what I'm going to do, so that's okay. I'm going to just get out of here for a second, back to lobby. So I'm going to go into Bad Lieutenant Pepe, and I'm going to, so this is a script that's just in Python rather than a browser. It connects as if it were a web browser, and it starts invoicing and paying invoices just in a loop. So you can see now that it's invoicing and digesting the discovered paid pixels. So these counters going up are rather quickly. So actually, yeah, here you can see pixels being bought, and they're sort of being bought in chunks of 50 at a time. Yeah, it's stalled for some reason. I think that has to do with I'm screen capturing, so my hard drive's kind of locked right now. Oh no, I think I might have ended. Yeah, okay, yeah, no, sorry. That was expected, but yeah, it bought these pretty quickly, and you can see it was going at a pretty good clip. So I'm actually going to do the same on the $1 Million homepage. Yeah, I think I did a handful and then stopped, and that was the plan. So I'm going to kill that. So we'll go into the $1 Million homepage. And again, yeah, this is many megabytes worth of state. I might get rid of that now because it's getting in the way of the actual. Okay, so I'm gonna do the same here for the $1 Million homepage. So yeah, this guy as a client gets all the megabytes worth of state. Yeah, this is going a lot slower than it should be, and I believe this is hard drive related because yeah, it's going burst. This is just a very cheap hard drive in this this particular laptop. Yeah, there it goes. I see my hard drive light was getting grouchy, so yeah, it just took a while for it to get going there. So yeah, as you can see, we're well in excess of what's it? Yeah, okay, so there you can see the pixels coming in. Yeah, this is only a dual core laptop. You can see Chrome is now taking all my CPU. And yeah, my screen recorder is taking a chunk, so hopefully this is still recording all right. But yeah, so that's where I'm at scale-wise. And then yeah, as I mentioned, the JSON transfer is a bit of a problem. So just as a comparison, if I can get this computer to respond to me, let's see if Chrome does any better. And kill that. So anybody watching this should be familiar with Satoshi's Place. Hopefully there's no porn today. But just in case there's porn, I'm going to make that small. But yeah, the point here is on Satoshi's Place, it is 1,000 by 1,000. But there's only 16 colors here on the palette, as you might have noticed. So I haven't dived into what is actually, what is actually being transferred on the wire for Satoshi's Place. But this tells me that there's only 16 possibilities for colors, so that's probably only 4 bits of information per pixel, which is a different thing than really what we're doing here. We have essentially 24-bit color per pixel, and then the prices are embedded. There's different metadata on top of that 24 bits per color. So yeah, we have several times more information to transfer. And also thinking if a visitor is visiting, he's probably not just going to see one piece of art. He's probably going to flip through a couple. So that's kind of in our assumption here. Okay, so that's my brain dump on scaling right now. Yeah, sorry for a couple of the rough edges along the way. This is kind of a tricky one to orchestrate. But yeah, hopefully in the future I'll do more videos like this as I go. Certainly I'm developing. So yeah, thanks for paying attention. Thanks for taking interest in this, and good luck and have fun.